This project involved creating an automatic fabric cutting machine. The machine was required to cut through various fabrics of differing thicknesses and reduce user effort when cutting patterns for sewing. The main goals we wished to accomplish during prototyping were conducting extensive fabric tests and determining the robustness of our original design, which included the overall moving vehicle and the blade mechanism. As it was important to be organised, we reviewed daily tasks regularly. These meetings helped us improve productivity as we could prioritise and delegate jobs effectively.
Due to the limited information available on fabric properties, fabric testing was an essential part of the process. A range of fabric offcuts with varying textures and thicknesses were used. Another aspect of this experimentation was to conclude the best fabric treatment that could be applied to improve the overall cut outcome. The coefficient of friction was approximated by rolling a vehicle wheel across treated fabrics. Fabrics with low rigidity and more flow, like satin, were susceptible to creasing and needed sufficient grip. For tougher, thicker fabrics, such as twill, it was important that the treatment did not greatly increase the cutting force. Overall, the best fabric treatment was found to be an adhesive spray, because it was the most effective in keeping the fabric stiff as well as for stabilization against the cutting surface. Cutting force was also measured using scales, and it was estimated that the vehicle would need to be about 1.2 kilograms. However, in reality, the machine was able to cut with a minimum weight of about 820 grams.
The blade mechanism part of the design was required to lower to different depths, and initially this was going to be carried out with a screw-like system powered by a stepper motor. However, there were some issues with the original design, and it was apparent early on in the prototyping that some further design development was necessary. One issue was fits and tolerances after components were 3D printed. It resulted in improper assembly of the lowering mechanism.
Moreover, while the initial design focused on lowering the blade to different depths, it was brought to our attention that there may be aspects relating to the cutting force we hadn't yet considered. In addition to depth setting, some of the things we needed to think about were features such as load-varying capabilities to adjust cutting force, as well as blade speeds. For this, it was useful to revisit the underlying physics to fully understand all the contributions to the cutting force. As for a base designed to replace the original one, a simple rack and pinion was chosen. As can be observed, the stepper motor was connected to a fixed pinion, allowing the rack, which is fixed to the rotary blade, to move up and down. One point of note was that there were many iterations of the gearing system. Initially, due to the stepper motor increments, we believed that a highly fine-toothed gear would be required, but as this was difficult to attain, we opted to assemble a gear train. However, upon further inspection, it was found that the stepper motor was indeed capable of finer increments, which meant that the gear train was no longer required.
In order to cut fabrics of different thicknesses, we needed a method of varying the cutting force. Our research led us to two methods, the first of which was the lead screw, with a spring suspension system attached to the bottom. The suspension system ensured that the blade did not turn with the lead screw, whilst retaining precision depth control. The second method considered was to attach the blade to the bottom of a rack. A pinion would be used to adjust the position of the rack, which would then be tilted downward. This would adjust the vertical component of the force itself. After discussing our research with professors and amongst ourselves, we realised that the solution was simpler than it seemed. The load variation could be controlled by lowering the blade more to increase the cutting force, with torque provided from the motor.
This part of the prototyping was with regards to the main framework of the machine and how it moved. The vehicle consisted of a laser-cut board upon which components were assembled. Although the original design used acrylic, plywood was used for prototyping. The machine was three-wheeled, with two regular wheels at one end, held in place by brackets below the board, and a caster wheel at the other. The blade mechanism, consisting of a rack and pinion fixed in place with specially printed components, was fixed along the same axis between the two wheels. Circuitry and additional weights were placed on the board. The weight provided by these components was just as important as any other functions of these components, as it stopped the machine from being lifted by the blade lowering instead of the blade going through fabric. The machine was controlled with an Arduino Uno, with its output pins being used to control the stepper and DC wheel motors via the attached Bluetooth module. At first, the 5-volt terminal in the microcontroller was used to power these components as well, but this, though providing rated voltage, was not enough power for the wheel motors to move the full weight of the machine, nor the stepper to cut fabric, so further tests were conducted using a 9-volt battery to power the motors, with a USB connection still being used to power the Arduino from a laptop. This proved to be significantly more successful.
While the machine could cut straight lines, it could not perform turns. This may have been due to a combination of factors such as weight, power supplied, geometry of machine, etc., and these would be some considerations for further prototyping.
Fabric research that we conducted allowed us to better understand the scope of the project. This project has shown how design is an iterative process and exposed limitations that would be explored more in further prototyping. The practical nature of this project has bridged gaps between theoretical knowledge and its application, and let us explore aspects of design that had previously been left unconsidered, making us better engineers.